Welcome to acids and bases. So this topic is going to be delivered into two sessions. In the first session, we're going to take a look at acids. Then in the second session, we're going to take a look at bases, pH scale, and indicators. With that being said, let's get started. So what is an acid? An acid is a chemical substance which, when dissolved in water, produces hydrogen ions, H+, as the only positively charged ion. So when you have a substance and you dissolve it in water, then you get only hydrogen ions as the only positively charged ion, then that substance is an acid. Now let's take a look at this hydrogen ion. How many electrons does an hydrogen atom have? 1. How many protons? 1. How many neutrons? 0. So hydrogen atom has no neutron. With that being said, if it has a charge of positive, the hydrogen ion, the charge of positive 1, it means it has lost 1 electron. Therefore, it has 0 electrons. So what fundamental particle remains of this hydrogen ion? It doesn't have any electron and it doesn't have any neutron. Therefore, it is just a proton. Okay? So sometimes they define an acid in a different way. In this way, an acid can also be defined as a proton donor. So an acid at the end of the day can be defined as something that donates a proton. So when you dissolve it, it removes hydrogen ion as the positively charged ion, so it donates a proton. If there's any other substance in whatever reaction, it's going to provide the proton, which is this hydrogen ion. So this is another definition for an acid. So we take a look at types of acids. There are two categories of the types of acids. Here we're going to take a look at the types of acids in terms of where they are taken from, or the substances which makes them up. So the first are called mineral acids, which are taken from minerals, and they're also called inorganic acids. So here are examples of mineral acids. So we have hydrochloric acid. So this one is taken from chlorine. So hydrochloric acid, the formula of course is HCl. Then we have got nitric acid, which is taken from nitrate. So nitrate plus hydrogen forms nitric acid. We have sulfuric acid, which is taken from sulfate, and we have phosphoric acid, which is taken from phosphate. So these are mineral acids. The second types of acids are called organic acids, and these are found in the organic matter of living things. Generally, organic acids are weak acids, while mineral acids are very strong acids. So here are examples of organic acids. We have methanoic acid, which is taken from methanol, the formula is this. Ethanoic acid, which is taken from ethanol, the formula is this. Propanoic acid, taken from propane. Butanoic acid, taken from butane. So these are examples of organic acids, which are also weak acids. So we're going to start a process called ionization. So what is ionization? Ionization is just the process of forming ions. Any process that ends up forming ions is called ionization. So acids dissolve in water and produce hydrogen ions, H+. According to the definition of an acid, this is what happens. An acid, when it dissolves in water, it produces hydrogen ions as the only positively charged ions. So these are examples of ionization. Hydrochloric acid in water is going to produce hydrogen, positive, and chlorine. Nitric acid is going to produce hydrogen and nitrite. Ethanoic acid is going to produce hydrogen and ethanol, the ion for ethanol. Sulfuric acid is going to produce 2 hydrogen atoms and sulfate. Then phosphoric acid is going to produce 3 hydrogen ions and phosphate. So this is ionization, where an acid breaks down into its constituent ions. One of them, which is of course that the one that makes it to be an acid, the hydrogen ion. Another way in which we're going to categorize acids is in terms of strength. So in terms of strength, acids can be categorized into two. So the strength of an acid is the measure of its ability to produce hydrogen ions. An acid that is able to produce hydrogen ions more than the other is said to be a strong acid. So there are two types of acid, the strong acid and the weak acids. The weak acid is an acid that partially ionizes when dissolved in water. So what this means is it doesn't have the strength to produce hydrogen ions as much as a strong acid. So in other ways, when you dissolve it in water, it doesn't fully ionizes, it partially ionizes. And you can tell that by the fact that ionization of weak acids is a reversible reaction. So by reversible reaction, it means the reaction is going to be indicated by this. What it means is when you when you get the acid, you ionize it, you get the constituent ions, you can again combine the ions to get back the acid. So when such is possible, then it's a weak acid. An example is ethanoic acid. So ethanoic acid undergoes this ionization, produces hydrogen ions and this ion. So by this symbol, it shows that this is a reversible reaction. So you can combine these again to make ethanoic acid. So this shows that the ethanoic acid hasn't fully ionized, it has partially ionized. So another type of acid, supposed to be two here, sorry, is the strong acids, which I already mentioned. A strong acid is an acid that completely ionizes when dissolved in water. So a strong acid, you put it in water, it completely ionizes. You cannot combine the ions that are produced to get back the original acid. Examples of strong acids and their ionization, maybe we just look at one. So hydrochloric acid is a strong acid. And remember, it is also amino acid. So this is the fact that is being told again in a different way. So hydrochloric acid ionizes to form hydrogen and chlorine. So if you look at this symbol, it shows that you cannot reverse the reaction, you cannot get back the acid because the acid has completely ionized. Next, we're going to take a look at basicity of an acid. So this is also called protosity of an acid. So basicity or protosity of an acid is the number of moles of hydrogen ions H+ produced from one mole of an acid. So I won't go deep into what a mole is, but we are going to have an idea. So we're going to do more concept, we're going to understand more about the mole. So what we're talking about, the basicity or protosity of an acid is how many protons or how many hydrogen ions it produces from one mole of that acid. So this is a simple fact, no? And there are three types of basicity that we're going to study. The first is called monobasic acid or monobasicity, meaning that acid that produce only one proton. So these are the examples. Hydrochloric acid, you dissolve it, you're going to get, you dissolve one more of hydrochloric acid, which means just one hydrochloric acid, you're going to get one hydrogen ion, as we saw in the previous reaction. The same is true for nitric acid, the same is true for ethanoic acid. The way to tell is just to tell the number of hydrogen atoms that are here. We have one here, so it's going to produce one. We have one here, it's going to produce one. Here we have one, we're going to produce one. This one, this hydrogen is part of the ethanol, so it's like a radical. So it has nothing to do with the acidity of ethanoic acid. Only this hydrogen here. So all these are monobasic acids. The second is dibasic, which has two. So example is carbonic acid. You can see there are two moles of hydrogen here, or there are two atoms of hydrogen here. So it's going to produce from one more of carbonic acid, you're going to have two hydrogen being produced. The same is true for sulfuric acid. From one mole of sulfuric acid, you're going to have two hydrogen ions. The third is called tribasic, which means it produces 3 moles of hydrogen ions from 1 mole of an acid. So this is an example of a tribasic acid, which is phosphoric acid. And from the number of hydrogen atoms here, you can tell that 3 hydrogen ions are going to be produced from 1 mole of phosphoric acid. Finally, we take a look at physical properties of acids, then we'll finish this part with chemical properties of acids. So for physical properties, what are the physical properties of acids? The first one is acids have a pH number less than 7. What is pH anyway? So we're going to start this in the next video, but pH is just a value that indicates how acidic or how basic a solution is. So there is a meter, which is called the pH meter. Once you put it in a solution, it will tell you the pH value. So acids always have a pH less than 7. So pH is for acid numbers like 1, 2, 3, 4, 5, 6. Acids turn blue litmus paper red. What's a blue litmus paper? So this is a paper that is used to indicate acidity or basicity of a solution. You're given a solution, you put a litmus paper. By the color changes, you are going to know if it's an acid, if that solution is an acid or a base. So acids turn blue litmus paper red. Acids have a sour taste. You put an acid in your mouth, it's going to have a sour taste. Lemon has got acid, so you put lemon in your mouth, it will give you that sour taste. Chemical properties of acids. The first is acids react with reactive metals to form a salt and hydrogen gas. So hydrogen gas, of course, is H2. So acid reacts with reactive metals. So if a metal is not that reactive, it cannot react with acids. There is a series called a reactivity series, which all metals with their which lists metals in terms of their reactivity. The most reactive are put on top, the less reactive are put on the bottom. So hydrogen is somewhere in or on that list. So metals that come after hydrogen on that reactivity series, they are less reactive than hydrogen. So these metals which are less reactive than hydrogen cannot react with an acid. But these ones which are more reactive, they react with acids to form a salt and hydrogen gas. In the next video, I'm going to show you a reactivity series so that you have an idea. So example of such a reaction is this reaction. So sodium is very reactive and it is high in the reactivity series. So this sodium reacts with hydrochloric acid, which is an acid, and when this happens, sodium is going to combine with chlorine and hydrogen is going to be emitted as the hydrogen gas. So we're going to have sodium chloride and hydrogen here. The second property is acids react with bases and alkalis to form a salt and water only. So acids react with compounds which we have not yet looked at, called bases and alkalis, to form a salt and water only. This reaction is called neutralization reaction. Why? Because the substances that are formed are neither acidic nor basic. So you can view substances in terms of acidity has been in 3 categories. There are those which are acidic, those which are not acidic, the opposite, they are called basic or alkaline. Then on the middle, there is neutral substances which are not acidic, which are not basic. So it's like a number line. On the left of the number line, there are acidic substances. On the right, there are basic or alkaline substances. Then on the middle, there are neutral substances. Examples of neutral substances are salt and water. So when you take an acid and a base, you mix them in a reaction called neutralization, you're going to get a salt and water. Since salt and water are neutral, then this process or this reaction is called neutralization. Here's an example. So we have sodium hydroxide. This is an alkali. So you react this with hydrochloric acid, which is an acid, you're going to have the metals, the metal combining with a non-metal, sodium combining with chlorine to form a salt, sodium chloride, and this OH is going to combine with H to form H2O, water. So all neutralization reaction have the same ionic equation. So you're going to have a situation where you are being asked to write the ionic equation for a neutralization reaction. Sometimes they can't give you a neutralization reaction, but you have to write the ionic equation. So the ionic equation for any neutralization reaction is this. We are going to have a proton, which is just hydrogen plus, reacting with hydroxide ion to form water. So the two are always in aqueous, and water is going to be liquid, as you would expect. Number 3, acids react with carbonates or hydrogen carbonates to form a salt, water, and carbon dioxide. So acids react with carbonates, such as sodium carbonate, or hydrogen carbonates, such as sodium hydrogen carbonates, to form a salt, 1, water, 2, just like in neutralization, but in addition, carbon dioxide gas is formed. So this is an example. I've got calcium carbonate here reacting with sulfuric acid. So calcium is going to combine with sulfate to form calcium sulfate. Then also the hydrogen is going to combine with one of the oxygen to form water. Then the carbon is going to come out with 2 oxygens as carbon dioxide. So this is the third chemical properties of acid.